Hi, welcome to Expanse Tension Theory channel. Thank you for being here. This video is an introduction to the series to welcome you in, to explain what the theory is about, to explain the channel content and how to access further materials. So, firstly, what is Expanse Tension Theory all about? Well, it began in 1986, 40 years ago, at primary school. My headmaster at primary school introduced the topic of Newton and Einstein's achievements in science, explaining all of their incredible achievements to mathematically and geometrically account for gravity, but with a limit, with a weakness, with an unresolved issue: the cause, the real physical cause of gravity. You see, both of them can explain gravity and gravitational attraction using maths, using the curvature of space-time, but nowhere is there a real mechanical cause to what we experience and what they could predict. It triggered a 40-year passion for gravity science, and that was the single objective. I have read science passionately, obsessively, for 40 years. My particular passion, I read the science of the history of science. My favorite is Robert Hooke, the guy who originally came up with the inverse square law, although it was Newton that formalized it. Sadly, Hooke, many of you only know from Hooke's law, but he was the guy who originally came up with the inverse square law, if you read a book called The Man Who Knew Too Much. Anyway. So, moving forward, in August 2025, I was on a plane between the UK and Morocco, and an epiphany-like moment struck my head, and it went like this. If the universe is expanding above us, as I believe, and nearly every other scientist believe, the universe is expanding. Hubble showed that that was true nearly 100 years ago, 1929. If the universe is expanding at between 67 and 74 kilometers per second per megaparsec, and that was happening above me. But below me, at the Earth level, there's no expansion. We're not expanding. I'm not expanding beyond a bit of middle-age spread. Expansion there, no expansion there. Now, as an engineer, that invokes a necessary, inevitable tension gradient. And where there's a tension gradient, there is a reactive force. That's necessary. Now, what then is gravity? What do I believe gravity is? Well, gravity then becomes an emergent phenomena as mass resists the expansion of the universe, triggering a net flow imbalance of expansion above us and no expansion beneath us. And that's enough to trigger a tension gradient reactive force that we experience as gravity. Now, that's a physically real idea if you use quantum field theory. So I then, the first thing I did was test that. So I used some online quantum field theory calculators, built up that hypothesis, and started testing the idea for the Earth. The first number out of that work was minus 9.81 meters per second squared. Ooh. Gravity on Earth. I repeated it across many platforms, got the same result, the idea of mass resisting expansion. I then replicated that work for Moon, Mars, Venus, Sun, again replicated their gravitational attractions as we know it. That's a pretty big deal. But I need a medium scalar field. I need a substrate to represent that net flow imbalance. So I started researching scalar fields in quantum field theory. And I found there's a type of field called a singlet scalar field. It's gauge invariant, it's physically real, and it can be an all-pervading field. It doesn't disrupt any known science that we've ever produced. So my research says there's a type of quantum field theory permitted field that could support this idea, a singlet scalar field. And then I found if it can couple to the Higgs portal, mass, with continuous density dependence, it can actually represent lots of things in the universe. So now let's explain that. So, density dependence. This whole thing is about density dependence. Let's look at the evidence. And actually, that's what I am. I'm a problem solver. I've been cataloguing evidence of anomalies, paradoxes, mysteries in the universe for the last 40 years, looking for patterns and trends in the data. A problem solver, if you have to put a label on me. Not a scientist, not a physicist, not a mathematician. Okay, a problem solver, looking for patterns and trends. And here's the pattern and trend I found. Dark matter, the terrible name of flat rotation velocity of galaxies. Galaxies are traveling in the outer low density regions too fast for the amount of baryonic mass to support. Void lensing, you may have heard of gravitational lensing. So gravitational lensing is where light bends around massive objects. And Einstein, with Eddington's support, proved that that was true over 100 years ago. But void lensing is where you have a divergence of light passing through the deep, low-density void of space. There's a trend coming. Dark energy, late-time acceleration of the universe, not constant now, as proved by the James Webb Space Telescope, a dynamical shifting acceleration of expansion of the universe, now slowing down, and I believe that to be true, needs some kind of form to cause that. Well, late-time acceleration of the universe, an expanding universe in volume, same matter, means falling density, necessarily. Okay, so dark matter constructs and dark energy constructs have the same underlying factor, both in falling low-density regimes. That's interesting. Now, if you invoke a singlet scalar field that couples with Higgs mass, Higgs licensed mass. Now let's go back to CERN. CERN, Geneva, 2012, proved that electroweak symmetry breaking of the Higgs VeV, quantum field, assigns matter with a property mass. Now you might hear about mass, but mass is significantly, insufficiently defined scientifically. What do we know? Objects have inertial mass. Kinetic energy is half mv squared. It takes energy to move things in the absence of friction. What is inertial mass? Nobody knows. Newton proved that gravity is proportional to mass about 350 years ago. Einstein proved that real proper time and time dilation proportional to mass 120 years ago. So gravity, inertia, time, all proportional to mass. And in 2012, CERN proved that mass emerges from a quantum field theory process called electroweak symmetry breaking of the Higgs field. So I deduce logically that electroweak symmetry breaking triggers the orthogonal emergence of gravity, inertia, and time. Now that gives lots of really cool possibilities. Now, what does the theory say? And you'll see these videos in the channel. I'd recommend watch the channel in order because I'm slowly learning my trade. So watch the series in channel. I hope it will make more sense, but you can dive into particular videos. So when it comes to galactic velocity, my theory says that as you move from the high dense bulge in the center of a galaxy to the low dense outer halos, you pass a density threshold, and the density threshold is 10 to the minus 21.6 kilograms per meter cubed. Now I've shown that density threshold applies from normal Newtonian rotational dynamics supported by gravity and mass to a point where you have dark matter rotation unsupported by baryonic mass happens at that density threshold because mass becomes coupled to the expanding scalar field of the universe. So this field that I've postulated in expanse tension theory is expanding and has been expanding. It wants to expand. It's been filled with energy. It's a real matter energy field. It has expanse tension ripples and it's propagating itself out. Mass is resisting it. So in the outer regions of galaxies, mass can suddenly become coupled to an expansion and it starts to pull, starts to apply a tension. Now that additional tension, matter forces win. They hold together, but under greater strain. That greater strain can support the additional rotation speed we see, dark matter. Void lensing, the same, a falling density regime where the divergence of light into the deep low density void is almost like a refraction characteristic of passing between density regimes where the physics change beyond density regimes. Dark energy, falling mass density in the early universe about 6 billion years ago from where we are now, falling mass density, a density threshold released the coupling and released the universe to start to accelerate as it expands, is the idea. Okay, but go back to the orthogonal emergence of gravity, inertia and time from electroweak symmetry breaking. Look at the early universe description. There are about 12 defined phases of plasma, radiation, various epochs through the universe, early universe. They are purported to have existed all within less than a second, and most of them within 0.0000000 something of a second. So tiny fractions of a second for all these nuclear processes of decay. There are, by the way, 66 paradoxes of the early universe, which means that timing doesn't make sense. But what if you overlay the orthogonal emergence of gravity, inertia and time from electroweak symmetry breaking, which is halfway through that process? It means before electroweak symmetry breaking, you don't actually have gravity, inertia, or proper time emergence. Now, after electroweak symmetry breaking, where you have those things, you then adopt what Einstein taught us. In fact, why don't we? We have the most ultra-dense period in the universe of all time, way beyond the density of the core of a black hole or a neutron star, and we didn't apply time dilation, which is proportional to gravity. Why didn't we do that? In fact, that seems stupid. Anyway, then instead of microseconds, you can allocate with time dilation, proper time, many, many millions of years of time dilated time for the universe to evolve. That can explain supermassive structure in the early universe, which is completely unexplained, where within only a few hundred thousand years of the Big Bang, we see supermassive star formation and galaxy formation of organized spiral galaxies way before they could have evolved with the time allocated currently. Well, what if we have time dilation? They have all the time in the world. So there's a video on the early universe. Then at the opposite end, so as you get more and more dense, compact objects, pulsars, neutron stars are famously glitchy, is the word. They reach a density where they get really glitchy. And that glitchiness, again, I believe is a density threshold over the core of neutron stars, where again, there's a coupling of mass to the expansion of the universe. And that starts to pull and rip and tear and shear those neutron stars apart. Okay, and that can start to explain a very extreme density in the upper regions of density. Now, here's the big thing. When you reach a black hole density and the event horizon, we now have physics born out of real material, matter and energy. And you have a number of processes happening. One, the event horizon could actually just be the point where this scalar field, where real gravitational forces start to take over and give us the effect of the event horizon without the need for an event singularity. So if you look at the paper and work, it's called, in the paper, it's called Expanse Tension Theory, Hypothesis 3, Part B. There's a deep dive into explaining what the event horizon could be and the elimination of the mathematical singularity. Now, how do we get to that point? Well, it's a deduction. If electroweak symmetry breaking only emerges in the universe once density falls to a certain threshold, well then go reverse the process to extreme density threshold. Maybe you have symmetry restoration. Maybe we have the opposite of the assignment of mass to matter. And if we have symmetry restoration, if you're with me, you have the de-emergence of gravity, inertia and time. That's clever. It means the heart of a black hole isn't where time freezes. It isn't an infinity. Proper time disappears, as does gravity, as does inertia. And maybe that's what a black hole is. Now, if we should want to get rid of this singularity of black holes and the Big Bang, because they are physics-destroying concepts. If we can think of an idea where we can remove the singularity, we then can restore investigative physics. And that is an exciting point. Now, that's the big stuff. Small stuff. Go and look at, if you've heard of the Thomas Young double slit experiment, a 224-year-old experiment, which got really interesting about 100 years later, when Taylor started firing a single particle at a time at two slits. And he found that firing a single particle at a time at two slits still produced the famous interference pattern on the detection screen. The mathematicians of the day later started going wave-particle duality, superposition, and the Copenhagen interpretation of a probabilistic, unknowable, random universe, which expanse tension theory can remove. Now, this would be huge for quantum mechanics. Again, the probabilistic, unknowable universe destroys physics. It says we can't see further, the Heisenberg uncertainty principle. But what if it's not true? Now, if you look at my Thomas Young double slit experiment, you'll see in Solving Science 14b an animation that shows if you include a all-pervading singlet scalar field, the same field that solved galaxies and dark matter and dark energy and the Hubble tension and other things, if you have this scalar field that's density dependent, you can actually trigger the wave within the field, and it's the tension gradients in the wave that then guide the single particle. I believe the single particle remains a particle. It never becomes a wave. It's not wave-particle duality. It only ever passes through a single slit, which is why when we look, we see the single slit. The interference pattern comes from the interference of the wave, not the particle, and that would trigger high and low regions of tension gradient in the scalar field, again, resulting in the interference pattern that we all see. The report, by the way, studies 224 years of everybody who ever ran that experiment in every single experiment setup, and all the new different experiment setups, and it seems to be able to explain every single result they ever got. That's exciting. Then, and I hadn't heard until recently, the Richard Feynman glass reflection paradox. This is amazing. Go and have a look at the video on that, and again, you can access and read the paper. Right, what does this say? If light reflects off glass, you get 4% of light reflected back. But if you start stacking up glass in the background as bulk material, the amount of light reflected can increase to 16%, and keep stacking glass and it will drop back to 4%. Now, the paradox goes like this. Well, if light reflected off the front surface is varying the amount of light it is reflecting, it must have some intelligence of the bulk material behind it, which it doesn't sample. Okay. Now, density dependent tension gradients of the bulk material would explain why you have a front surface change in the way light reacts. So look at that paper. What I'm doing now is probably the toughest thing yet. It's called the Correspondence series, and please have a look. So this is probably the most challenging thing. Correspondence in science means that new science needs to encompass knowledge and laws of the past. There's a correspondence. Now, for example, Newton's laws of gravitational attraction were flawless, they were perfect, and they hit a domain limit, mostly the orbit of Mercury. Now, Einstein came along, and with his theories of geometry and curvature of space-time, he could reduce to Newton in this domain, but actually against certain relativistic regimes, he replaced Newton where Newton's theories no longer became applicable. Again, there was a correspondence of Einstein reducing to Newton within a domain. Now, if expanse tension theory has a hope of being right, it needs a correspondence series of all known existing science. I've designed a structure so far. There are 10 designed elements in the correspondence series. There's an introductory video, and I've now launched the first paper 1 and the video for paper 1. Expanse tension theory has reduced to kinematics of Galileo, Kepler, and Newton. Now, that's a pretty big deal. Go look at the video. It's a really big deal. Read the paper. It's a really big deal. By the way, it has now been reviewed by 12 of the world's leading AIs that say it's accurate and correct mathematically. I wish I had a human to talk to, but I don't, so I'm using the 12 AIs. 12 global AIs have read and reviewed that paper together, concluded it is accurate. General expanse tension theory reduces to Galileo, Kepler and Newton. It can reproduce, it can reconstruct them. Now I'm going to start moving forward onto the inverse square law of gravity and then special relativity, general relativity, thermodynamics and quantum mechanics. But can general expanse tension theory reproduce and reconstruct known science and physics? So far, paper 1 is a pass. So, one really important vital question. I'm not a physicist or a scientist or a mathematician. So am I a deluded narcissistic armchair physicist thinking I've solved the entire universe? The evidence suggests possibly, maybe. The evidence says retirement age engineers are the type to kind of go for it. Maybe. You decide. I think about it every day. I think about that question every day. And I don't think most deluded narcissistic, deluded armchair physicists ask themselves that question as much as I have. So I am extremely cautious and nervous that I might be in that category. Most people in that category don't put forward 7,000 pages of evidence based on advanced statistical problem solving and analysis to support their claims. I think that's quite rare, might be in my defense. Most don't put out a 42-channel series, making all of their ideas available to be torn apart under proper academic professional scrutiny and those who care about finding science. So all my ideas are out there to be interrogated, and I'm looking for that validation, verification, or falsification, and maybe terminal death. I'd actually like to know why this is categorically wrong so I can move on with my life. That would be wonderful. Haven't found it yet. So, at the moment, I'm not able to break expanse tension theory. Please work your way through this 42 episode series. Work in chronological order. It will make more sense, I believe. Explore these ideas. I had a conversation recently with someone. I think half of science is wrong. I don't know which half of science is wrong. And for every theoretical physicist now, I think you have to start to make a judgment call. What do you believe could be wrong? Because at the moment, if we're constrained and confined by existing science law, as it were, we cannot make progress. All of the science laws we have today confound to the point where we can't make progress, because together they put up boundaries that we can't progress. So I think every single theoretical physicist has to decide personally, what science of the day don't I believe? And I'll tell you my biases. This is true. There is no dark matter, dark energy. I think they are horrendous terms where we labelled a problem with something that could be an answer. So we labelled a problem with maybe answer. That's a horrific protocol. So dark energy, dark matter are not things. The observations are real. Flat rotation of galaxies are real. Void lensing is real. Late time acceleration, dynamical process are real. But the answer that they are anomalous, mysterious, invisible, undetectable sources of matter energy, no, they're not. I believe they are quantum field couplings of an expanding quantum field to mass. Then there's a really deep thought, and you might see the difference of the word expanse tension theory and general expanse tension theory. This is a real thought. I only set out to solve gravity. That was all I wanted to do. And I had this density-dependent coupling. Then something really cool happened. I realized the same density-dependent environmental coupling could happen with all 19 entities in the standard model. Okay, now, be careful because this is a big step. Okay, so at the moment, the standard model of physics has 19 entities measured, I think, between 27 and 28 ways, depending how you measure neutrinos. And they are all fixed, constant parameters. They are fixed. There is a mass of an electron. And that's it. There is just one fixed, constant mass of an electron. I think we have limited perspective of human beings on the planet. Okay, there are something like 126 orders of magnitude in density across the universe, and we've experienced a tiny, tiny proportion of them. So I believe everything is environment dependent variable, including all 19 entities in the standard model. Let's say they become environment variables and they can change depending on the density of the environment. I'm talking extreme differences beyond any human empirical test. No one's ever been there. But there is a hint. Humans have got 5 deep space probes. Voyager 1, Voyager 2, Pioneer, 10, 11, and New Horizons. Go look them up. They're all displaying anomalies and mysteries. They're all suddenly going a bit haywire. There's lots of things going on with our deep space probes, and they are all at or over or beyond the general expanse tension theory defined threshold. They're all around a mass average coarse-grained baryonic mass density of about 10 to the minus 21.6 kilograms per meter cubed. Okay, now at that point, the mass of those space probes becomes coupled with expansion of the universe. I think they're suffering additional strain energy. Okay, so I think if there are all of these anomalies happening with our deep space probes, the density regimes that they've just passed, and go look it up, they're transiting into some really bizarre science. By the way, the Atlas I3 Atlas comet that came in was displaying a huge amounts of extra gases produced off the surface. Again, I believe it was a transition from low density space into our more dense space of our solar system, which could have explained some of those anomalies. I think there's a video on that too. So it's a big step. If general expanse tension theory is the general extension of expanse tension theory to the entire standard model of physics, a pretty big deal. Now, that paper, if you look at, it's called Hypothesis 4 as that upgrade. If you look at that, the claims in that paper solve a phenomenal amount of problems and anomalies in the universe. Right, what else to explain? There's a video on water. Now, water is fascinating, the most anomalous material in the known universe. There are 44 paradoxes of water, of things about water we can't explain. It's a freak of nature, water. When you cool it down, it gets less dense, which is bizarre. It's the opposite. It has a maximum density at 4 degrees C within the liquid range, which is bizarre. It beyonds in inversely logical ways for specific heat capacity and compressibility. And there's a whole load of other things that water does that is really, really strange. What the paper does is group and categorize those anomalies. And it proposes water is just the perfect antenna for this scalar field, for a density-dependent tension gradient field that might be causing water to be a perfect expressivity. It's expressing this density-dependent scalar field. It might just be perfect for showing the evidence of general expanse tension theory, which is why water is so odd, versus all of the other hydrogen bonded liquids. And if you see in the paper on water, you'll see against all of the other hydrogen bonded liquids, water is a bizarre anomaly. So look at that. Again, imagine if we use general expanse tension theory to solve water. So the next videos I'll start to load are going to be more videos in the Correspondence series, looking to see if it can reproduce science. I'll make a claim. I don't want to be doing this. I want to engage with people. I want to talk to people. I want to share ideas with people. I only wanted to solve the causal mechanism, the physically real mechanism of gravity. And until I can engage with people, I'm forced and locked into trying to solve all these other problems, which I'm absolutely not a specialist in. And again, I'm using all the resources at my disposal. I'm the director of a research program, as it were. My team are called Chat and Grok and Claude, Copilot and Gemini. I typically use 10 to 12 AIs to review everything I'm doing. be clear, they all make lots of mistakes and errors, and I think the skill is detecting and checking again. So it's a research role of using these. The ideas are mine. The ideas are not coming from the AIs. The ideas are mine, and again, the developments of these series are mine. I'm conducting research. That for me is clear. The mathematics is incredibly complicated. I'm trying to keep up, but again, with humility, I would love to be working with a Friedman-Gaussman. Remember, Einstein, he wasn't great at maths. He had to kind of outsource a lot of his maths to Friedman-Gaussman, and understandably his wife helped him as well. Sadly, my wife isn't a world-leading mathematician, but that's the way it goes. Anyway, that's expanse tension theory. It's exciting, it's fun, and if you are interested in trying to solve the universe, you have to start by knowing the problems. What are the problems, anomalies? And that's one of the things that I'm really cataloguing in this work. What are the anomalies of the universe? What's wrong? What don't we understand? And it comes down to this. Our leading theory of the day is general relativity, Einstein's general relativity. It's amazing, but it doesn't work everywhere. Can't explain dark matter, dark energy. It can't explain the Big Bang or the event horizon or the singularity. It can't explain the double slit experiment or the Richard Feynman glass reflection paradox. Can't explain a lot. Okay, it has a domain limit where general relativity is valid. That's where I believe expanse tension theory has moved further into a domain beyond the density that Einstein had measured. I have considered, is it fair? Could Einstein have come up with general expanse tension theory? And actually, I think he could, if he listened to Edwin Hubble. Now, he did eventually listen to Hubble, but he didn't entirely believe him, and he added his cosmological constant, then regretted it and removed it. But actually, if Einstein really thought about expansion of the universe above us and realized we weren't expanding, he could have reached a tension gradient reaction to the net flow imbalance between the two. He could have got there. There was enough information there. He didn't know about late time acceleration. That came along many, many years later, knowing that the acceleration of expansion was happening. But expansion he knew about. So maybe he could have got there. Anyway, please subscribe. I think it's interesting. Please share. If you know someone who loves science. My desire is only to learn and study and understand more. For me, the pursuit of science and physics is to understand the universe we live in. And I need people to look at the paper, because I'm working alone and that's not good, that's not healthy, and need to move on to other things. Please subscribe to the channel, and thank you very much for watching. Bye-bye.